Okay, VPC peering. We discussed yesterday. Anyways, let me repeat it once again as people were confusing. I have two VPCs. I have an instance in one VPC, right? I have one more instance here, one more instance here, one more instance here. So can this instance talk to other instance directly?
Yes.
So how it will talk means the instance want to talk, the request will go to the route table. From there, it will come here. Yes or no?
Yes, sir.
So here, see this. I have a route table, right? For that, for example, let me take this private route table or whatever, right? So here it is saying that series, right? 10.3 is any IP address from one IP address is this rule, right? Any IP address from this can talk to one more IP address within this range locally, right? So this instance will have one IP address within this range. This instance will have one more IP address within that range, so they can talk to each other locally. Yes or no, guys?
Yes, sir.
That rule is that. Right here also, same. This VPC also has one more route table, this route table, right? Default VPC has this route table. It is saying they can talk to each other locally. So they can talk to each other locally, it is saying, right? So that instances can talk to each other locally. Fine, no problem. Okay, no issues with that. But I want to do VPC peering. VPC peering means what? Making connection between two VPCs and making them as a single VPC. So now I want to do VPC peering. So what I will do is I'll take one of them as a requester. So one VPC should be a requester. For example, this default one is going to be the requester. Now the conditions are both the VPCs should be in same range, either in same AWS account or different AWS account. So I have both the VPCs in same AWS account, my AWS account, default VPC, my VPC. So default VPC, my VPC, both are in same account. If you want to take in different accounts, you can take, no problem, but those should be in same region. So these two VPCs are in same North Virginia region. Their CIDR range should be different. So this CIDR range and this CIDR range, both are different. So all my issues are solved. So same region, different CIDR range, right? So no problem. I want to merge them. So how to do VPC peering is, so this is going to be the requester. It is going to make a request to this VPC. Hey, I want to do peering with you. All right. So once it make a request, so let me show you. So it is going, there is one option called as VPC peering. Go here. So my default VPC. Okay, this is the deleted one. Last time I deleted. Okay. So let me create one VPC peering. Create VPC peering. Name for that. My demo VPC peering. Okay. So which VPC? Who is going to be the requester? This is going to be the requester. See, requester ID. So my default, this default VPC is going to make a request to my VPC. Hey, I want to do peering with you. Okay, this is the CIDR range. So this, the acceptor, right? This my default VPC, this is going to be a requester. It is going to request this. So now this is going to be the acceptor. This is in same AWS account or different AWS account? Same AWS account, my account. If it is in different AWS account, you can select my AWS account and give this, right? So, and one more thing, we can do peering with the new regions, other region also we said, right? So this is, you can select that. So which region it is, okay? You can select that as well. So for example, this one, in that also there will be one acceptor, it is not showing. For now, it is in the same VPC for us, right? So within this region only, select this. Which VPC? So this my default VPC is a requester. So for us, this is the acceptor. We are selecting this. Okay, CIDR range also different. So it will allow create VPC peering. Now peering is not yet done. Just it made a request. Okay, peering connections. If you go here, it is showing as pending acceptance. Okay, my default VPC has made a request to my VPC. Hey, I want to do peering with you. Now this has to accept. This my VPC has to accept it. If it is in different AWS account, you need to go to that acceptor account. But for us, requester and acceptor in the same AWS account, right? So my acceptor account is still here pending. Pending acceptance. I need to accept this. Go here, actions, accept request. So before accepting this thing and making a request between these two, right? One question I have. These two instances can talk to each other directly. Yes or no?
Yes.
These two instances within the VPC can talk to each other directly with the private IP address. Yes or no?
Yes, sir.
So now what I want to do is I want to do peering. So I want to merge this as a single networks. Okay, I'll create as a peering, means two VPCs will be there, but acts as a single VPC, right? So there is a peering between this. Now these two instances are local instances. Yes or no?
Yes, sir.
So once I accept the request, the peering will be done. So let me accept that, accept the request. So you need to go here, go to actions, right? Accept request. Accepted. Done. That VPC peering is active. Done. Now, if I try to make a communication from this VPC, it will go via this route table, and to this instance. Will that be possible? It has to work like this, but will it work now?
No.
See, we merged the VPCs, but it doesn't mean that means we did the peering, but it is not a single VPC. Even now, there are two VPCs, but the instances in that each VPC looks like a local to each other. So this instance is local to this VPC and this VPC. This instance is local to this VPC, right? Now this instance want to talk to this instance with the private IP address. Now the communication is not possible. Why it is not possible? Actually, it has to happen like this. This instance need to talk to this instance through private IP. Directly it will possible. Via route table, it will go this. Likewise, it need to talk to this instance locally with the private IP address. So via this route table, via this route table. This has to happen, but this will not happen even after accepting the peering request. Why?
Route table connection.
See, yes, correct. In the route table, if you go to your route tables, see, this is the route table. Okay, this is the route table, right? Okay, let me take this. Okay, this is the route table. Okay, public subnets. It has two subnets, right? Okay, so now let me, what I have to do is, what is the rule here? Any instance, two instances within this IP address can talk to each other. Okay, right? These two instances are within the IP address range. So, right? These two instances within this IP address range, they can talk to each other locally. If these two instances are within this IP address range, they can talk to each other locally. But now these are also local. I want to make the communication for this as well. Now what I have to do is I need to take this IP addressing range of my VPC. Right. So here I have to go edit routes. Right. This is the route table of my VPC. Here in this VPC, I am already allowing this traffic local, right? This VPC internal traffic I am allowing in the route table, but now I need to allow the traffic of this VPC as well, because this instance and this instance are local now, right? So what I have to do is 172 dot, what is that IP? 31.0.0/16, right? Which thing here is VPC peering connection. You have to select this one, right? That acceptance we did, right? Demo VPC peering request accept, that you have to select here, save changes. Now, so which route table we did is this route table. For this route table we did. So the instances which are created in the two subnets of this route table, this route table has two subnets. All right. So the instances which are created within this subnets can talk to this instance locally and these instances locally. But if the private route table has two subnets, this has two subnets, means total I have four subnets, two has been assigned to public route table. This is the default route table. The other two subnets which are not associated any route table, that will be associated to this route table by default. Now the instances which are created in private subnets cannot talk to the instances which are on this subnet. So here also I have to allow that rule. In this route table also, how many route tables you have, everything you have to allow there. So edit routes, 172.31.0.0/16. Done. Save it. So now here I did this. And the both here two route tables are there. On both the route tables, I allowed this traffic. So if any request comes here, right? We want to go to this instance, the request will come till here. Route table check. Okay, rule is satisfying. I want to allow this as well. So let me allow this. It will go here. Now, before going to this instance, this route table is there. Here also you need to allow the traffic from here, right? A request is coming from here with a different IP address, a range, for example, 10.30.0.1. This instance IP is this. It is coming here. It will text. Now it is allowing only this traffic. Two instances within this IP address range can talk to each other directly. But this IP address is not within this range. This is a different series. So in this route table also, you need to allow this traffic, right? Two-way. So in this route tables, this VPC has route tables. There you need to allow this traffic. In this route tables of this VPC, you need to allow this traffic. So what I'll do is, we'll go to the route tables. This is the default route table. The default VPC has only one route table, right? Public one, right? Here you go, edit routes. Here, same 10.30.0.0/16 only I gave, I think, 16. Here, 16. Internet, that VPC peering connection, and save it. Now, if I create any two instances, they can talk to each other directly. Understood? Do I need to show you that? Yesterday I showed you. Do you want to show me? You create and you launch one instance in this VPC. You launch one instance in this VPC. You launch one more instance in this VPC and try to talk to them. The connection has to happen. So let me create that. If you want to show quickly, launch instance, this one, I'm going to select in default VPC. So default VPC I'm taking as default VPC, right? This instance. Okay, this is, I'll name it as default. This is created in default VPC. I'm going to create one more. So now I'm creating other one in my VPC. So anything, for example, private, right? A public one or anything you can create. Let me give enable public IP address. No problem. It will not, you can communicate with that. So let me give this public IP. See, security groups are VPC specific. If you have created a security group in one VPC, that will not be available in other VPC. Security groups are VPC specific. Okay, VPC. So security groups are VPC related. My VPC. One security group created under one VPC will not be available in other VPC. Now what I'll do is, I want to talk from my default VPC. Okay. So from one of the instance, okay, from one of the instances, okay, this one wants to go via this and want to talk to this instance. So what I'll do is, I'll make a connection. First, I'll connect to this. First, before connecting to this, first let me check the connection, whether it is happening or not. What I'll do is, I'll connect to that instance. Okay. So I connected to this instance. Okay. I connected to this instance. To this instance, from here, I want to connect to the other one, to the private IP address. But to connect to that, I need a PEM file. I don't have the PEM file there, right? Here, if I type ls, my PEM file is not there. So let me exit scp-i Okay, let me use the connect command, just modify it. CP. Okay. :/home/ user. So both the instances are using same PEM file. So now I copied. Let me connect to that. Okay. So this is my instance where I have PEM file I copied here. So I connected to this instance. There I have a PEM file of this instance. Now I want to connect it to this using this, right? With the private IP address. So what I'll do is, so this is my VPC instance, right? Which is there here. So here, I'll take this connect command. Okay. So I'll take the private IP address. You observe here. So this is my instance on a public VPC. No, sorry, default VPC here. This instance from here, I'm trying to connect to this using the PEM file, right? Private IP address. So what I'll do, I'll take the private IP address of that instance. See here, I was on 3196. No, it is saying, okay, when the problem is permissions, read permissions are there, not there. chmod port. Okay. It's not connected. Now let me try to connect. Now you see it is connected from 96 to 143. So this is the IP address of that is 1.143, right? And this is 172.3.196. So connected from that instance to this instance directly. Yes or no, guys?
Yes, bro.
Check ping also will work or not. Okay, so that is a proof that within the it is treating both the VPCs as VPC instances as local VPCs. Okay, ping is not ping also working. You see here, ping also working from that instance to from this instance to from this instance to this instance via this route table. It is going like this. If I delete that route, whatever we added, right? Even one we delete, even if this allows, if this is not allowing, it will fail. If this allows and if this is not allowing, then also it will fail. Understood? VPC peering. Have you understood, guys? So we need to take two VPCs, peer them. After doing peering, it will not work. What I have to do in the route tables of both the VPCs, we need to allow the traffic of the other VPC. Okay? Yes or no, guys?
Yes, sir.
Yes, bro.
Okay. So now let's delete this. So what I'm going to do is I'm going to delete the peering connection. Okay. So delete first. This is a peering connection, right? So first delete peering connection. Okay. So it is asking while deleting the peering connection, whatever the changes you delete related route table entries. In both the route tables, we added entries, right? To allow here, to allow the traffic of this, here, to allow the traffic of this, right? It is asking, do I want, along with the VPC peering connection, do I want to delete the routes as well? If you select this, if you don't want, do not delete the route table entries, right? In the private route table, it is going to delete this. In this public route table, it is going to delete this. In this default VPC route table, it is going to delete this entry. I want to delete that entries. I don't want that, right? Select that, delete it. Done. Right? So it will delete. It is deleted. It after some time it will disappear from here. Okay. Next, what will happen? Is there anything we did right? Let me delete that VPC also. My VPC. So this is the custom VPC we created. Let us delete this. Delete VPC. So unable to delete VPC because this VPC has one running instance, has one more instances. It is saying there it has one instance running. Okay, it has one more NAT gateway. NAT we need to delete, instance we need to delete. Okay, first let me delete the instance which is there in that. So EC2, so my VPC instance, let me terminate it. And NAT is there. NAT also we want to delete. Okay, so let me go to NAT. Let me delete this also. Okay, deleting this. Now let me go to my VPC and try to delete this. Okay, this is an instance, right? Okay, shutting down. It will take some time. So now even if I delete my VPC, it will not delete because they are in progress of deletion, right? Delete VPC. See, it is saying VPC NAT is still there. Terminated. NAT is not terminated. Let me try once again. ENI is there. Okay, let me go there. ENI. VPC Peering. Let me delete this. Subnet ENI. In use. Okay, we should not delete this. This is for default. I think that is for default. But it is showing ENI is available. Let me go here. VPC is 71871. This is default VPC. 871 is default VPC. This ENI belongs to that. Oh, okay. Let me expand. This is not an issue. This is related to something else. Unable to do it cannot be deleted until you complete the following actions. One is my VPC available. Okay. This we have to delete it this saying. Okay. Let me go there. This one we have to delete. Why? Okay. Let me delete this. Currently in use. Who is using this? To AE. Okay, I think that still VPC peering is not yet done, deleted completely. I think that is it is showing. So actually we are trying to delete my VPC, but it is asking to delete the ENI of this as well. So that might be the because of that. What is that? Peering. Okay, let me check that. Else it will not point to that. So these are deleted. Okay, let's try to do that after some time. But for now, we created and we deleted NAT. Okay. Next, is there any elastic IPs? Just we need to make sure everything is deleted. Elastic IP, delete this, else it will get charged. Okay, for the NAT, whenever we created a NAT needs one elastic IP, right? We created it. So whenever you delete a NAT, you need to delete this as well. Next thing, let me last to give a try for this VPC. If not, we'll wait for some time and delete after that. It is deleting, I think, because of that. See, along with this VPC, it is going to delete one internet gateway, one NACL, one private, right? Two means the subnets, right? These and all it is going to delete. Two private, two public, one route table, right? These and all it is going to delete. So I'm going to delete this VPC. I think that elastic IP was there. That's why it's So with this, we deleted our custom VPC successfully. So we know how to create a VPC and delete a VPC. The next, the final concept is ENI, Elastic Network Interface. This ENI is nothing but a private IP. Okay. So if you select an instance, EC2 instance, right? So how many private IP addresses are there? Here for this is one IP address, right? Now if I go to ENI here, Elastic Network Interface, network interfacing, right? Network interfaces. You can see this one ENI is there. One ENI is there. Okay, for which subnet? So private 3196. You observe here 3196. 3196. So for one IP address, one private IP address, not public, one private IP address, one ENI will be created. In case if you want two private IP addresses for a single instance or public also, right? So you can create an ENI. Okay, for generally we do it for private, right? So why we need, right? So if you want to attach two private IP addresses for an instance, then you need to go for this. So how to do this is go for network interfaces here, create network interface. ENI means Elastic Network Interface. Give some description, demo purpose. Okay, which subnet? So you need to check where your EC2 instance is there. Which subnet? EC2. Let me check. My instance is in which subnet. So this is in US East 1. A availability zone it is. Actually, it is availability zone, but in the default VPCs, they took availability zone name as the subnet name. So US East 1A, right? 1A. Okay, that is actually a subnet availability zone, but in the default VPCs, they have given availability zone name as a subnet itself. We create subnets in different availability zones, right? We give public one, private one, like that. US East 1A, public one, like that we give, right? So, but they give availability zone name as a subnet name. So it is saying this. Then you need to assign one security group for this. Create network interface. Done. So now if you see this, scroll here, it is saying demo one, right? Available. So the other one is in use means the EC2 instance, this EC2 instance, this EC2 instance has this private IP address already. So for this IP address, in ENI is there. So it is in use. I want to assign. So along with this, I need to have one more private IP address for this. So what I'll do is I'll go here, select this, right? Create an ENI, go here, attach, which you want to attach to this instance. Default VPC, attach. Done. Now if you go to my EC2 instance and refresh here, select this. How many IP addresses it has now? 3196, which is older one, and 2120, new IP address it has got. Understood, guys? So like this, we can attach multiple IP addresses for an EC2 instance, right? So through ENI, we do for private IP addresses. So like this, we do, right? So how we have to do? Just go and create in the network interfaces, create network IP, right? So if you already have IP, fixed number of IP, you can give this, or else if you want to auto assign, AWS will in the availability zone, when the subnet, right, whatever the IP addressing range is there, from that one it will pick. If you have a custom IP, no, I already in that, for example, 255 IP addresses, I need to give a specific IP, custom IP, right? You can give it. If you don't want any random number, then random IP, you can select this, right? So it is going to create an IP for this. So private IP, remember, through ENI will assign this. In which scenario we need to give? For example, I need to give you, so I have an EC2 instance. I don't want to give my private IP to you for some supporting purpose, right? Or maintenance purpose, or sometimes I want to share an IP address with you. So I'll give it. Later, you may misuse it. So what I can do is, instead of giving my original IP, instead of giving my EC2 instance original IP, right? So instead of giving this IP, what I'll give is, I'll give this IP. Right, you do your actions, right? You whatever you want to do in this instance, I need your help. You did it. So what I'll do is, after you did that, I'll go and delete my IP address, delete my ENI, detach, right? So detach. I want to detach from a network interface. Yes. Okay. So something it showed error. Reset demo one, first one. Okay, delete. Let me delete it. Then it cannot be delay the selected in ENI network is currently in use. Okay, just let me detach it. Just a second. Detach it. Post determined. Improvement from attachment. Okay. Let me detach it. So it is in use now. It will show as in use, in available. Okay. No, it is not showing. Just a second. Delete it. Cannot be deleted. Why? In use. Okay. Okay, fine. So whenever my work is done, I can delete that. Okay, fine. Why it is showing like this running instances? Here it has been detached. If you see here, it has been detached. It has only one IP address now. But here, I think it will take some time. I think it will take some time. We are very fast. Now it got detached. See, now it is available. It took some time. That's it. But we were in hurry. So now I want to delete it. So you delete it. So for maintenance purpose, right? In other real-time scenarios, like when we want to share an IP address with someone, but it should not be permanent one. Temporary IP address I need. So create it, assign to them, and once they use it and done it, just delete that IP. So even if they try to connect to your instance, as the IP is deleted, they'll not be able to connect to it. But randomly, if your AWS instance attach that private IP to some other instance, it will be connected to other instance. But for maintenance purpose and all, whenever we need one temporary IP, we can use this ENI. So ENI is nothing but a private IP address. So attaching multiple private IP address to an instance is possible through ENI. Understood, guys? Is it clear?
Yes, bro.
So do you know how to do VPC peering? Yes or no?
Yes.
So you know how to create ENI and attach a private IP address, multiple private IP addresses to an instance.
Yes, bro.
Okay. So that's it. That is the end of VPC. Do you have any questions? Next, we will start through IAM. Okay. Do you have any questions about VPC? Okay, then good.